Hello and welcome to Database Management Systems. I'm Jovita Christie, and in this video, I'm going to explain to you the third normal form and the voice code normal form in the normalization process. 3NF stands for the third normal form. Here the condition is that the relation should be in 2NF. That means the relation should be in the second normal form and there should be no transitive dependencies. So consider this table. This table contains 4 columns: ID, name, project ID, and project name. And there are 4 people: Paul, James, Ruth, and Jude, and they all have unique IDs. And they all work on some project. And we've mentioned the project ID as well as the project name of the project they work on. So Paul and James both work on analytics, and Ruth and Jude both work on accounting. So this is what our table looks like. And now the dependencies, the functional dependencies that are present here are ID determines name and project ID, and project ID determines project name. So what's the meaning of this? ID determines name and project ID. This means if you are given the ID of somebody, you can tell who the person is and on which project ID that person is working. Now at the same time, there is a second functional dependency, which is project ID determines project name. So directly, if I give you the ID of a project, you can give me the name of the project, because if I tell you 1, then 1 is coming twice in this table, and both the times the name of the project is analytics. And if I tell you 2, then 2 is also coming twice in this table, but both the times it is coming with accounting, and so it is settled that 1 stands for analytics and 2 for accounting. So that is another functional dependency. And this is an example of a transitive dependency, because you see the ID of a person can determine the project ID of the project the person works on, and the project ID determines the project name. So this is transitivity, because project ID is repeating once on the right and once on the left. This is the same as explaining transitive property in mathematics, where you say x is greater than y and y is greater than z, and hence x must also be greater than z. So this is the same type of thing happening in a functional dependency. And you can see the redundancy, which is duplicate data caused, which is present in this table. You can see analytics is coming twice, accounting is coming twice. And every time you want to add a person working on analytics, you will have to repeat analytics. And so this goes on. Now, of course, this causes problems which are known as anomalies. And these are the same which were caused in when we studied 2NF. So these are the same anomalies which were caused in 2NF. And the first anomaly, of course, is the insert anomaly. If you want to insert a new project and you don't know yet who's going to work on that project, then you will have to leave the ID and name blank or null. And again, null values are not desirable in any database. The next problem caused is the update anomaly. So if you want to update the name of any project, for example, you want to update from analytics, you want to make it data analytics. So in this case, you would have to perform the update twice. But if you had a bigger table where you had like 15 people working on analytics, then you'd have to make the change 15 times. And that's once again not advisable. It's a very costly operation when you have to update so many times. And delete anomaly. So if you want to delete some project, and you might actually end up deleting that employee also. For example, if I delete analytics, then I end up deleting everything about Paul and James. And this table could contain more data about Paul and James, for example, their phone numbers or their addresses or their email addresses, and all these things could be present. And I'd end up deleting all that just because I want to delete some project. So as you see, this is not a very efficient design. because of the transitive dependencies, and so also this table is not in the third normal form. And to bring it in the third normal form, of course, what we need to do is to split it into parts or to decompose it. The first part that we can make is the project ID and project name. This is the first part. So you can see already a lot of redundancy is gone with this itself, because I now have one project name occurring only once, because I'm only going to store it once here. And the second one that I've created is ID name and project ID. That remains the same from the original table. Now just removing that column has reduced my redundancy to a good extent. And what I have now in terms of functional dependencies is that the dependency between project ID and project name has now shifted to the first table only. And the second dependency is just ID determines name, and you could add project ID there, of course. So this is the second dependency, and this is present in this table. Right, so now there is no longer a transitive dependency in the same table. Of course, when I say that you can add project ID here, there is still no transitive dependency, because project ID determines project name is present in some other table. So transitive dependency must happen in the same table, only then it's a transitive dependency. So you see now my tables are in the third normal form. And for most cases, performing normalization up to 3NF is quite alright, and by this time you'd have a very efficient design. But for the purposes of theoretical knowledge of this subject, you have other normal forms like BCNF and 4NF and 5NF, which makes your design even more efficient. And we're going to go ahead and look at those now. So 3NF is completed, and we're going to move on to now let's go ahead and see what is BCNF. BCNF stands for Boyce-Codd normal form, and the condition here is that the relation should be in 3NF and all determinants must be candidate keys. The determinants are the left side part of a functional dependency. So BCNF makes everything very tight, normalization wise, that everything, all functional dependencies must have primary keys or candidate keys on the left hand side. So if you consider this table, it contains students Philip, Paul, Joseph, 3 students, and courses DB SQL, and teachers John, Matthew, and Mark. Now this is what the table looks like, and you can see from the table data like Philip is learning DB and is being taught by John. So this is what your data looks like. Now these are the functional dependencies present here. You can see that student and course together determine who is the teacher. For example, if I say that Philip is studying database and who's teaching him, then you have one single answer, which is John. And if I ask you Philip is studying SQL and who's teaching him SQL, then also you have one single answer, which is Mark. So also if I ask you the question, who is teaching SQL to Joseph, there's only one answer, Mark. And who's teaching DB to Joseph, you have again one answer, Matthew. And who's teaching DB to Paul, one answer, Matthew. So because you have only one answer for each question you ask, student and course, they determine teacher. Now, the second dependency here is that teacher determines course. So if I ask you which subject is being taught by John, then it's only DB. If I ask you which subject is being taught by Matthew, it's once again only DB, because although Matthew appears twice in this table, both the times he is teaching database, which is DB. And if I ask you what course is being taught by Mark, you'll tell me it's SQL, because although Mark comes twice in this table, both the times he's teaching SQL. So this is BCNF, and this is where the question comes that on the left side, do we have a candidate key? So student and course together, they do form a candidate key, right? Because if you look at it, student and course form a unique combination. For example, Philip and DB together never appear again in the table. Paul and DB also never appear again in the table. Joseph comes once with SQL, once with DB, so those combinations are unique too. And Philip and SQL is also unique. So all combinations of student and course are unique. And that is why student and course together form a candidate key. And because that's a candidate key, our first dependency, which is student and course determine teacher, is alright. But the second dependency, which says teacher determines course, that's not alright. Because here on the left hand side we have teacher, and teacher is definitely not a candidate key because it contains duplicate values like Matthew, which is coming twice, and Mark, which is coming twice. So this is not a proper dependency as per BCNF, and because of teacher determines course dependency, this table is not in the Boyce code normal form. And once again you can see that it is causing a lot of anomalies. And to provide a solution, first we have to understand what the anomalies are. So these anomalies are, first of all, insert anomaly. So if I want to insert a new course, a new teacher, I have to always keep repeating several things. I need to have data. For example, if I want to insert a new teacher, I need to know which course that teacher is teaching, which student is being taught. So all that insert anomaly is still present. Then the update anomaly. If I want to update the name of a course, or I want to update the name of a teacher, then I have to update in several places. And there's also the delete anomaly. If I delete one row because let's say I want to delete one teacher, then I'm deleting the name of a course as well as the name of a student. For example, if I want to delete Mark, then I'd be deleting all data about Joseph and Philip and also the entire course SQL. So you see, this is not a proper efficient design, and it's definitely not in BCNF, and so we have to do something about it. And of course we will, and we will be doing decomposition as usual. So what is decomposition? Once again, in this, the first one we are doing is we are putting student and teacher together, and the second one where we are putting teacher and course together. You can see right here. So teacher and course are separate now, and student and teacher are separate. So now what happens is the dependencies that you had earlier are now reduced, because now when you look at it, this original table contains no non-trivial dependency at all. Because you can see now, if I ask you Philip is having two teachers, I can no longer find a functional dependency there. And if I ask you who is Mark teaching, then also you have two answers. So there's no functional dependency from teacher to student. So there is no non-trivial functional dependency. And in my second part, I have a dependency teacher determines course. But here also a lot of duplication of data has been reduced, because now the name of the course is not repeating every time a teacher teaches it to the student. Because obviously one teacher is not going to teach only two students. He or she is going to teach hundreds of students. And in that case, you don't want to end up writing the name of the course 100 times. Just the name of the teacher should be fine. So in this case, now both the relations are in BCNF, which stands for Boyce code normal form. And that's what BCNF is. I hope you understood 3NF and BCNF, and please stay tuned and watch the next video in order to understand the fourth normal form and the fifth normal form. See you in the next video, and thank you for watching.